Hey all, it's Fox. Today I want to talk about one of my favorite topics, simulation theory. Specifically, I want to talk about how it relates to the double-slit experiment and consciousness. This video will lay the groundwork for a series of future videos on the topic. The double-slit experiment remains one of the most baffling and revolutionary experiments in physics. At its core, it demonstrates that particles such as electrons and photons exhibit both particle-like and wave-like behavior depending on whether or not they are observed. This peculiar quantum behavior has led some to question the very fabric of reality, with some theorists proposing that this experiment provides compelling evidence that we live in a simulation. If reality changes based on observation, could it be that our universe functions like a computer simulation, rendering only what needs to be seen by an observer? Today, we'll explore the implications of the double-slit experiment, the connection between quantum mechanics and consciousness, and the tantalizing possibility that our reality is a digital construct. The double-slit experiment, a brief overview. The double-slit experiment is a simple yet profound demonstration of quantum mechanics. When particles such as photons or electrons are fired at a barrier with two slits and a detection screen behind it, their behavior changes depending on whether or not they are observed. If no measuring device is placed at the slits, the particles behave like waves, producing an interference pattern on the screen, suggesting that each particle somehow passes through both slits simultaneously and interferes with itself. However, if a detector is placed at the slits to observe which path the particle takes, the interference pattern disappears, and the particles behave like solid objects traveling through one slit or the other. This leads to a fundamental question: why does the act of measurement change the outcome? The very nature of matter seems to be influenced by whether or not it's being watched, which challenges our classical understanding of reality. This bizarre property has inspired interpretations ranging from the Copenhagen interpretation to the many worlds theory. However, one of the more provocative ideas is that this experiment suggests we live in a simulated universe where reality is rendered only when needed, similar to how video games optimize graphics by only loading visible portions of a scene. Consciousness and the role of observation. One of the most puzzling aspects of the double-slit experiment is the role of observation. In classical physics, measuring a system does not change its behavior in a fundamental way. In quantum mechanics, however, observation appears to force a system to choose a definite state. This leads to the idea that consciousness plays a direct role in shaping reality. The notion that consciousness affects quantum outcomes is deeply controversial. Some physicists such as John von Neumann and Eugene Wigner have suggested that human consciousness is integral to collapsing the quantum wave function, thus bringing a definite reality into existence. If true, this could imply that reality is not an objective construct, but rather a participatory phenomenon dependent on observation. This aligns curiously well with the idea that we might be living in a simulation. Others fall over themselves, arguing that consciousness can't possibly collapse the wave function and that some other elusive, unknown force is at play, but what that force is remains a mystery. Simulation theory, a digital universe. Simulation theory proposes that our universe is a sophisticated artificial construct, much like a computer simulation. This idea was popularized by philosopher Nick Bostrom in his 2003 paper, where he argued that a sufficiently advanced civilization could create simulations indistinguishable from reality. If such simulations are possible and civilizations run many of them, then statistically, it's more likely that we are in a simulation than in the real, base reality. The double-slit experiment provides a fascinating parallel to how simulations function. In video games, environments are not fully rendered until a player looks in a certain direction, a process called lazy loading or occlusion culling. If our universe is a simulation, it would be computationally efficient for it to only render reality when it's being observed. The fact that quantum particles behave differently when measured could be evidence that our universe operates on similar principles. Furthermore, some physicists have noted that the mathematical structure of the universe resembles computer code. Theoretical physicist James Gates discovered error-correcting codes similar to those used in digital communications embedded in the fundamental equations of supersymmetry. This raises the question: if reality is governed by a form of code, could that code be part of a sophisticated simulation? Quantum computing and the nature of reality. The rise of quantum computing adds another layer of intrigue to the simulation hypothesis. Unlike classical computers that process information in binary states, zeros and ones, quantum computers use qubits which can exist in multiple states simultaneously due to quantum superposition. This allows quantum computers to perform calculations that would be impossible for classical computers. If our universe operates similarly, storing information in superposition and collapsing reality into a definite state when needed, it would further support the idea that our reality functions like a quantum computation. Could it be that our reality itself is a vast quantum simulation operating on principles similar to quantum computing? Implications and philosophical questions. If we accept the premise that the double-slit experiment hints at a simulated universe, it raises profound questions. 1. Who or what is running the simulation? If our reality is a construct, is it controlled by an advanced alien civilization, post-human descendants, or even an unknown intelligence? 2. What is the purpose of the simulation? Are we part of a grand experiment, a historical reconstruction, or a purely entertainment-driven simulation? 3. Can we detect glitches in the simulation? If our universe is a simulation, could anomalies like quantum entanglement, time slips, or even paranormal phenomena be signs of computational errors or system updates? 4. What happens if we break the simulation? If we were to prove beyond doubt that we are in a simulation, would that affect its operation? Could it lead to a game over scenario? A quantum reality check. The double-slit experiment remains a cornerstone of quantum mechanics, defying classical explanations and suggesting that reality is far stranger than we perceive. While mainstream physics continues to explore the implications of wave-particle duality, some theorists argue that this experiment offers compelling evidence that we live in a simulated universe. The idea that reality is rendered only when observed is eerily similar to how modern computer simulations optimize processing power. If the fundamental nature of reality is computational, then the double-slit experiment might be the key to understanding our true place in existence. Whether or not we are in a simulation, the experiment forces us to question the very nature of reality itself, an inquiry that may eventually lead us to uncover answers that lie beyond the limits of human perception. Ultimately, while we may not have definitive proof that we live in a simulation, the double-slit experiment continues to challenge our understanding of reality. Whether through physics, philosophy, or future technology, exploring these ideas could be the key to unlocking one of the greatest mysteries of our existence. That's all for today. If you enjoy my content, please give me a thumbs up, subscribe, leave a comment, and share it with a friend. I appreciate your support, and we'll see you next time.